basically going to look at continuous probability and looking at a few examples on continuous probability. So again, firstly, we've got some about 2 slides summaries that you can just keep with you when you basically do the assignments as well, and for your exams. So in here is a bit of a definition that we will that you will need. Also, I have included 1 or 2 definition questions in this slide pack as well that you can look at. So basically, we're looking at what is a normal distribution, how it is shaped, those kind of things. But I will talk about that when we also look at some of the questions. Then I think, and that has now come up a few times on the chat as well. So when we talk about normal distribution, we can also say approximately a normal distribution, which will be the same calculation when you work it out. So they can tell you that you have a normal random variable with mean equal to 0 or standard deviation equal to 1. They can also say that your variable is approximately normally distributed with a mean equal to 0, standard deviation equal to 1. So that also then basically you will do the same thing. So just for when we look at the questions and when you do the assignment, when we talk about that, then it is basically the same thing that you look at. Okay, so what I will basically also show you, so I've already copied in the table that we will use, but I will basically also try to show you how you look for something like that and how you work with that. But first, we need to work out the question. When I look at study unit 6, 7, probably 8 as well, what I always start off with is to nearly draw a normal diagram for myself. So I will always start with drawing that normal distribution. And when we draw that normal distribution, Z in the middle here is equal to 0. Then basically we have to the one side of that, we will have a probability that sits in here of 0.5 and a probability in this area that is 0.5. And it will always be equal to 1, like we have seen in binomial, Poisson, discrete. It will always equal to 1, the probability. So when we have this, we can also say that the distribution is symmetrical, because what is the size on this side is exactly the same on the other side. And I think that is also nearly what you need to know when you use the 2 different tables. So the first thing that we look at in this question is using the standard normal table Z, calculate that the probability is bigger than minus 1,65. So basically minus 1,65. And again, if Z is 0 there, to that side it's positive. and to this side it's negative. So we have here minus 1,65. We need to get the probability of that side. Okay, so we need to get the probability of the bigger than minus 1,65. So when you look at your tables, your one table that is positive, and if you look at nearly the diagram at the top, it will have this area covered in. Then, and that was the positive table. Then if you have the next table, which is the negative table, it will have that area colored in. So when I look at this, if there's a value of 1,65, that area is the same as the area there, if that is minus 1,65. I think that if you understand that, then it's basically, it becomes much more easier to nearly see what the answers can be. So we need to get that big area. So if we go to the negative table of minus 1,65, we will get that value as 0,0495. Okay, so that area would have been 0,0495. So we need to get the bigger than, so then we need to say 1 minus that small area, and that would give us the 0,9505. Let me just erase that. Let me just make it. Okay, so 1 minus that would give us the 0,9505. The other way that we can look at it is if we go to the positive table, we will get this area for the 1,65. And that area will be what we have here, the 0,9505. Okay, so if we need the bigger area, like we can see there, it is the same as that bigger area. So then we can just use that number of 0,9505. And I think that is nearly where sometimes some of the answers is very confusing, because they go straight into the positive 1,65, where they ask the negative 1,65. So they go straight into the positive because of the symmetry of a normal distribution. Okay, so that is why, and I'll nearly repeat this every time that we are looking at the normal distribution. Okay, I know this is a lot to take in for the first one, but is it a bit better understanding nearly? Does it make a bit more sense now that we are going through it? Let me just get a quick check in with you guys.
Yes, I do understand it better. I was confused previously as to how the negative gets swapped into a positive.
Okay. Okay, so yeah, we'll do I think a few more of those ones because yeah, I know sometimes they go directly into the nearly the answer without explaining how it actually went from the positive to the negative or from the negative to the positive. Okay, so let's go into the next question. Okay, so the next question, the long distance calls made by employees of a company are normally distributed with a mean of 6.3 minutes and a standard deviation of 22 minutes. Use a normal standard table to calculate the probability that a call will last less than 7 minutes. So let me I want to highlight that rather. Okay, less than 7 minutes. So remember from the summary, so we will use this formula. Only in chapter 7, I think we start using the standard error where we have the standard deviation divided by the sample size. Not in this chapter yet, I think, but when we get there, I'll explain that as well. So we use this formula a lot. So it is basically Z is equal to x minus mu divided by standard deviation. Okay, so what I automatically do when I get this and I look at that, so less than 7 minutes, so my Z must be less than. So then automatically when I get to my Z, I know when I draw it on a diagram where to look for it, that you don't now, when you get the answer, start to nearly guess where it needs to be. Okay, so it tells me it is normally distributed 6.5, so that is your me, your me. Less than 7 minutes, that is your x, and you divide it by a standard deviation of 22. The other thing that is important to note, and again, just a small tip for the exams or maybe in your assignments as well, just make sure that everything is similar, so that you don't suddenly have hours somewhere or seconds that you need to multiply or divide with something. Just a small tip that at least all your units are similar. Okay, so then basically it is 7 minus 6.3, which gives us 0.7 divided by 22. So 0.7 divided by 22 is rounded off 0.03. Okay, so now we need to go, as always, I draw the diagram. In the middle is 0, so less than 0.03. Okay, and less than, so we need to get that area. Okay, so how big is the area in green? Anybody? How big is this area in green? if the mean is there 0, what is the size of this green area?
John, I'm just
Yes.
going to wing it. Yeah, is it that 0.5120?
Okay, so we'll get there. That will be your final answer. I first want to get the green area before I add that small area there as well.
Okay, yeah. Well, then the green area has to be 0.5 because the whole
Okay, cool.
speed.
Okay, so let's first stop there. Okay, so green area 0.5, and we've seen it with that as well. In the middle, half the one side, half the other side. So your green area 0.5. So if we add the blue area, it will be more than 0.5. So option 3, option 4 is not the option because those two numbers are smaller than 0.5. So in the exam, basically, we know that option 3 and 4 will not be valid. Okay, so that is just nearly also to assist you when you look at some of the answers. So we need a number that is bigger than 0.5. So we will go to the table where it is 0. So that is the 0 and 3. So it is 1, 2, 3. So across to 0.03. There our value is 0.5120, which is option 5. Okay, so from the table then, how I normally look at it is that first number goes down, the second number goes across. So first number goes down to 0.0, the second number goes across to the 0.03, and where is the number that you're looking for? 0.5120. So perfect, option 5. Okay, does that now become a bit more clearer from first one to second one? Bit clearer as we continue?
Yes, Jane.
Cool. Okay, so let's go to the next one. Okay, so now they ask it a bit differently. So now they say, suppose something is normally distributed with a mean, so of 0, variance of 1. So basically with that, they tell you it is normally distributed because that is in the definition. So when they ask you, suppose that is happening, what is the probability that z is smaller than minus 1,59? So with this one, basically you have your table. I always draw the 0 in so that I know where it's 0.5 and 0.5. So I need to look for minus 1,59. And they ask us smaller than minus 1,59. So we want that area. So if we want that area, it is definitely smaller than 0.5. So if it's smaller than 0.5, it can't be 0,9441. Probability is never negative, so it can't be that one. Then the other thing that I normally look at is if they give me something like this, I just look at nearly if there's a positive like that as well, and then I would actually go for that one. Just because this tells me that there's something in here that I nearly want to see if you will make a mistake, because we already said it can't be that. But before we now guess option 2, let's see if we can get to the answer. So on your negative table, we go down to 1. So 1.5. So negative 1.5. And we go across to the 0.09. 0.09. So where those two cross, we get the answer. And that answer is 0.0559. So that area there is 0.0559. Okay, so we didn't need to work out the Z. They gave it to us. So the only thing we need to work out is what is the probability of that small area. And that is then the 0.0559. Okay.
John,
Yes.
why
Yes.
could we not just use a table like that in the first question that you gave us? Why did we do the calculation? Because there they also gave us what Z was. I'm just trying to see if there's an easier way.
No, see, so
yeah.
So here it was, you're looking for the bigger than. So you could have used exactly that same table, but then you just needed to say 1 minus that. And you would have gotten to the same answer. So
Okay, so if it's bigger than, we always got to do 1 minus.
yes.
And if it's less than, then we don't have to. We can just use directly the table.
Perfect. Spot on.
Haven't you got a document with all these tips of yours?
I will, yes, I'll do something.
I'm just thinking, because there's a lot of
yes.
tips you give, and those are small little catches that makes it so much easier.
Yeah.
So as soon as one identifies it's smaller, then it's simple. Use the graph. If it's more than, then you just do the 1 minus that figure.
What I will do is I'll check if there's a previous exam paper that I've got a few extra, or few extra. I've got a few old ones that I will do that, and then I'll just scan it in and send it to you guys. But I will basically go through 2 or 3 papers and just show the things to look for.
Thank you.
Yeah, I'll do that. No problem at all. Because it just makes it easier. It definitely just makes it easier. Okay, so let's go to the next one.
Nikki put her hand up there.
Oh, yes, cool. Yes, Nikki. Is there a question? Don't mind if you unmute and ask something. Else we just continue. Okay, let's go to the next one.
Sorry, Jean. How did we get the 0.09?
Quickly say again, how do we get?
How did we know that we must use the 0.09? Because you're saying there that we must go vertically down the graph to get that one minus 1.5.
Okay.
How do we get the vertical 0.09?
Okay, cool. So that 1.5 is where I go down to the 1.5. And then the second decimal is the one that I go across. So if I just wrote that down as a decimal, it would have been 0.09, and the other one would have been 1.5. So that,
You
so
see, it's all those little tips.
yeah, so it is, that basically is the one going down, and the second one, the, what is this, pink or purple, is basically a cross. Yeah, so that's the small tips nearly. So I'll show you in the next one again, because
Yes, I get it.
yeah, I think that is. So let's look at this one, and now with the other ones they gave us the Z, here we need to calculate the Z. So let's just write it as, I nearly forgot how to. Okay, so X is normally distributed with a mean of 100. So I automatically put that in. Standard deviation, oh, wait. Okay, I'll check now the standard deviation. It's probably under there. That X is greater than 1,45. Okay, greater than. So the previous one was less. Less, we add that. This one greater than, so we need to use the bigger. So let me just see if I can quickly move. There it is. And the standard deviation is 20. Okay, so Z bigger than 145 minus 100 gives you 45. 45 divided by 20 gives you 2.25. So Z bigger than 2.25. Okay, so now before we even get to the table, that's 0, that's 2.25. Z bigger. So we want that small area. So if it is that small area, if that is 0.5, this whole part is 0.5, so that will be less than 0.5. So if that is less than 0.5, can't be that, can't be that, can't be that. Awesome. If you didn't now know how to use the table, you actually just have two that you need to guess from. Okay, so now we can go to the table. So this again is the positive table. So if it is the positive table, remember it gives us this whole area. So to get that small area, we will need to say 1 minus whatever we get out of this. Okay, so let's do it again as nearly. We will go down 2.2 and we will go across 0.05 because that will then be the 2.25. So go down 2.2, go across 0.05. Okay, so where that and that one meet, we have our value. Okay, and that is the value that we need to subtract from 1 because we want the small area. Okay, so that is 1 minus 0.9878, which is 0.0122. 0.0122. 0.22. 0.0122. Okay, so what you will see is that there was the answer for that. So if you just went straight to the table with a 2.25, your answer would have been there as well to take. But then, because we said it needs to be bigger than that number, we basically know that we need to look for the small value. So it is 1 minus that. Okay. So very similar to the previous ones. Here we just needed to calculate the Z. It just makes it so much easier when you nearly draw the normal diagram, and you can see I do it roughly. Doesn't need to be on scale. You just need to nearly have a visual of what is going on, because if you just had the visual, you could have eliminated 3 of these options even before you nearly needed to go into the next part of the question. Okay. So up until this point, does it start to make a bit more sense than before you started with this?
Yes.
Okay, cool. Okay, so let's quickly see what is the next one. Oh, okay, that was just showing that we could have gone, because of the symmetrical, we could have looked at the negative table for the 2.25 and gone straight to get that answer. So if we went to the negative table of minus 2.25, we would have gotten that answer straight from the start. So again, it depends on how comfortable you are with switching between the tables and knowing what to look for. But you could have used both tables actually to get to the answer. So it is about what level of comfort you have in the two tables. Just remember it is symmetrical. So the one thing about the symmetrical is that if that is 2.25, that area is just as big as that area where it is minus 2.25. So that is basically with a definition of a normal distribution. Yes, question.
Jean?
Yes.
I was wondering, if you have your probabilities up there, can you just say like 1 minus 2.25? Will it give you the same answer?
No, because when you're working with, you're changing the Z and you're not changing the probability.
Okay.
So it will give you a different answer.
Okay, I thought because maybe it was equal to 1, if you then just subtract that, it will give you the other value.
Wait. If you say minus the probability of the 2.25, yes. Sorry. So all of these need to be equal to 1. So if you set 1 minus that part or 1 minus that part, then it is fine. But you can't say 1 minus 2.25. So let me just understand you now correctly. Did you want to say 1 minus the probability that was in here?
No, I was talking about the 1 minus the 2.25.
Okay, see, then you're basically changing the Z value.
Okay.
So that, please don't do that. But now you know why. Okay, because when you're definitely changing the Z value.
Okay, and then if you have a probability of greater than, can you just go directly to the negative table?
Yes, yes, you can. So, and the same if you had so let's do it the other way around as well. So if it was minus 2.25 and we wanted the bigger area, so let's say Z was bigger than minus 2.25, we could have gone to the positive table to get that. So either or. So we could have now, if we needed to look for Z bigger than 2.25, we could have gone to this table again, to the 0.9878. So again, it is interchangeable, huge word, that you can use the tables.
So they're basically the complement of each other.
Perfect. Yes. Spot on. Spot on. And you can nearly, now that you say it, you can even check it in your two tables. So you can check where it is. The 2.0 is 0.9772. Okay, it's not there, but it will be the complement. Spot on. Okay, there's another question.
John,
Yes.
just a point of clarity for me, please.
Yes.
When you draw your normal distribution like you've been drawing,
Yes.
and if you shade to the right of the Z value,
Yes.
then you use the positive tables. And if you shade to the left of the Z value, then you use the negative tables. Does it work like that?
See, and most of the time. So, and that is where it becomes, so let's say if I shade to the right of the mean of that Z value of 0, then I will use the negative. If I now need to see, it's a difficult one to, so what I will do is, what makes it maybe easier is, how I use it is when I shade it and I know that it is going to be smaller than 0.5, then I use the negative. If I shade it and I know that I'm going to have a bigger than 0.5 probability, so even if it was that one, that was also, then I'm going to use the positive. So if I have an area that I know it's going to be bigger than 0.5, I use the positive. If I know the area is going to be smaller than 0.5, I use the negative. I hope I haven't now confused you with that, but that is nearly how I normally look at it.
Thank you.
Okay. Okay, this one is then more a definition. So let's look at what is in it. With distribution as a mean of 0. Standard deviation of 1. So what is that called? Okay, so that is just your standard normal distribution. We've seen that now in this definition as well. So what for me is also interesting, and that is nearly where did it say? So where was the 0 and 1? Mean equal to 0, standard deviation equal to 1. Okay, so there it was. Okay, so purely definition, nothing else. And it can be that you can get one or two of those still. I think when you look at some of your assignments, there has been a bit more definition kind of questions that I would have expected. Okay, so let's go into another question that we can look at. Okay, why didn't I put in a table? I'll copy one now. Okay, a psychologist has been studying, not psychologist, has been studying eye fatigue using a particular measure which he administers to students after they have worked for 1 hour. On this measure, she has found that the distribution follows a normal curve. Using normal probability table, what is the probability of students having a Z-score below 1,5? Okay, so that is my 0. $1.5. What is the probability that the students have a Z-score below 1,5? Below 1,5. And let me just check if, okay, so let's quickly copy this one in here. Okay. So let's just write it down as 1.50. Okay, so we go down 1.5 across the 0. So 1.5 across. Okay, so what is the probability that we get a score below 1.5? Now I would go straight to the Z table. I'm looking for the bigger portion, 0,9332. Okay, so again, when I looked at that, I knew it will be bigger than 0.5. So I could have said, not going to be that answer, not going to be that answer. So at least it was out of 3. So interesting. So the next one was an option. So if you just misread the table and skip to the next one, it would have been the option 3.95. So if you misread the 5 and went over to the 5 there, you would have gotten also an option. Just so if you just misread the table, there would have been 2 other options for you as well. Okay, so this one was nearly more straightforward. They gave you the 1.5. You needed to go to the table and to nearly look at the table and find your answer.
Sorry, John.
Yes.
So basically the whole part about the 1 hour writing on a computer was just chucked in there to mess one around.
Yes.
So it's completely irrelevant to the calculation anyway.
Yes.
Yeah, you see.
Yeah. See,
Sneaky.
and luckily for that, you didn't get that was the answer or something like that as well. Because if I now threw in 0.8413 as one of the options, then you would have started. Also, if they actually said to you probably a standard deviation, you would have said, okay, let's do 1,5, or you would have wanted to work out the Z, but they actually give you the Z. So that is also the one thing that happens sometimes, is that they give you more information that you actually need, and then you try to use all the information, but it's not needed, because it could have been now that and luckily it's not with some of the other subjects that there's an option none of the above, because with a 1 hour, I also first underlined it, but when I saw, okay, we actually have a Z score, so I don't need to work out anything else. But it can be that you nearly miss that also how it's written, and you want to say, okay, but maybe I must say 1.5 minus 1. I don't have a standard deviation, so what do I do? But yeah, so again, nearly the words to look for and the extra information that wants to nearly confuse you. Okay, so this is also a question that they like to ask. So nearly asking it in the reverse. So if a area to the right of a positive Z is 0,0869. So if the area to the positive, to the right of a positive Z, so we know, it's 0. We know it's positive, so we know it's that area that we're talking about, 0,0869. And they want us to work out what is that Z value. So we know the Z value needs to be bigger than 0 because it's lying somewhere there. So it's not negative. So I nearly want to say it is going to be that answer, just because they've given me the negative option as well. But let's also work it out. So you can use the negative table, look at that value in the negative table. When you have done that, your answer would have been minus 1,36. But remember, we're not looking for that value, we're looking for the positive. So that is why we then make it plus 1,36. The other way to do it is to say 1 minus that area. So if we set, or we need to basically, when we look at the positive, that area is going to be in the positive. We don't know what is the purple or pink area, so we need to say 1 minus the 0,0869. When we say 1 minus 0,0869, we get 0,9131. So in this table, we need to look for 0,9131. So there's 0,89, 0,9092. Okay, so it is less than that, bigger than that, 0,9131. So if we then look at it's 0,06, to this side. So 1,3. And the second value is across there, the 6. So 1,36, and that was option 2. Okay, so you could have used the negative table, but then you needed to remember that you're not looking for the negative Z value, you're still looking for the positive value, which you then turn into a positive because of the symmetrical way that the normal distribution is created. Okay. Is that a bit making more sense than when we started at 6 o'clock? And this is nearly a nice one to see how you can use the negative table and the positive table, or the negative Z table and positive Z table. Okay. Then the next one is also one that they love to put this into assignments and into exams, because there's nearly in one question again they can test if you can look at the tables. You can look at the negative table and the positive table, and then they normally ask you something like which one is incorrect, so you nearly need to look at everything. Okay, so again, when I look at this, I draw my diagram, and I first look at it and say if it can be an option. So if I look at Z bigger than 2,64, so 2,64 will be somewhere there. So that area will be small, and it will be smaller than 0.5. So then I know, okay, that might be a correct answer. If I look at Z smaller than 0,87, so let's say minus 0,87, and it is smaller than that, so I'm looking at that area, must be smaller than 0,5. Okay, I don't know yet, and I haven't looked at the table yet. Okay, between 1.5 and minus 1. Between 1.4 and minus 1.4. So let's say it is somewhere there, 1.4 minus 1.4. Okay, so if I look at that area that I need to calculate, I don't know. I assume it will be bigger than 0.5, but I don't know, so we need to work it out. Z smaller than minus 2.8. So let's get another color in here. Z smaller than 2.8. Okay, so that will be very small and smaller than 0.5. Okay. Answer bigger than 0.5, 0.9974. So they're actually referring to the whole other area where that is definitely then wrong. Okay, so I haven't even looked at the table yet. I just looked at what is possible answers. Okay, this one bigger than 0.4. Bigger than 0.4. So let's say we bring in another color. So let's say it was bigger than 0.4. Is that the same size as smaller than 0.4? Okay, so that one is definitely correct because of the symmetry. That is definitely a correct answer. Okay, so basically I have eliminated option 4 because just looking at what I've done, but let's quickly look at at these answers. So bigger than 2.64. Okay, so that is 2.64. So 1 minus that, you could have gone to the negative table to look at negative 2.64, but 1 minus 0.9959 does give us that answer. With this one, I don't have a negative table now in front of me, so we would have gone to the negative table, 0.87. You would have gotten that answer. But let's go to the 0.87, which is the positive. So 1 minus 0.8078 will also give you the same answer. So 1 minus 0.8078 will give you the same answer. That was also okay. So that would have been also correct. This one is a bit trickier. So let's end with this one. So let me, okay, so we've got 1.4 here. We've got minus 1.4 here. And we need to work out what is that area. Okay, so how I would do it is I would get that whole area of 1.4. So I will get the purple area. Then I would get that green area. And if I subtract the 2, I actually get the blue part. Okay, so look at it again. That whole area is the purple area. If I get the purple area, I subtract the green area, I sit with the blue area. So the purple area 1.4 is 0.9192. On your negative table, the 1 or the minus 1.4 will be 0.0808. So if I say 0.9192 minus 0.0808, I would have gotten the answer of 0.8384, which is then correct. Okay. So, and that is why I nearly, when we do study units 6 and 7, much more difficult for you to just do it on a screen, because it's nearly easier to draw the picture, to eliminate the areas that it can't be. It's much more easier for me to do it that way, because then you can really see what the answers can be and can't be. Okay. Is that a bit better for you? Next week we'll finish this last one, and then we'll go into the next study unit as well, that just continues with this kind of work. So is it a bit clearer than when we started earlier this evening? Okay, cool. Okay, guys, then have a very good evening. I'll schedule again the time for next week. Also, I'll look at what the load shedding schedule will be on my side. Then just plan around that as well. Okay, have a great evening, and I'll also post this hopefully this evening still. Otherwise, tomorrow morning I'll post the link to the session as well. Okay, have a good evening, everyone.
Thank you.
Thanks. Cheers.
Thank you.
Bye.